21.6 Part B, particle emitters. Of course, in the last one we know that particle cells means that inside it we have the internal resistance. Usually we hope that the internal resistance inside the battery or the power supply should be as small as possible, okay, to reduce potential difference across it, and also reduce the EPE loss in it. And how about the other one? The other one may be the meters, the measurement device. For emitter, in the ideal case, no resistance, no PD, no energy loss in it. Ideal case, 理想情況. But in particle, we have the resistance. But usually here, for emitter, this one should be connected in series, because we want to measure the same current to pass through all. Okay, this one is the ideal case. How about for particle one? This arrow, we know that is not zero, impossible, but we want to have something. What is it? Should be as small as possible. This one we will call it RA. Okay, so right here for emitter, we have the internal resistance of it, RA. We want to have this. RA is zero. It means that original I means that in ideal case, no internal resistance of emitter. But here, unfortunately, in particle case, RA should not be zero. Okay, should not be zero. Then what will happen? In order to find out the current, here, find out the current, we will have this formula, epsilon over the total resistance. Okay, in order to make it, make it as ideal case, we will think that we get this one. So in particle emitter, we want to make it ideal. It means that keep RA as smaller as possible. Next one should be the particle voltmeter. Particle voltmeter, similarly, we want to have infinite resistance. It means that this one, the current come to here, this junction A. We have two choices, pass through R or pass through V. But when this one pass through V, we will have the potential drop, energy loss. So we want to all the current come into here and here. Nothing will pass through it. But how to make it like that? In ideal case, this one is infinite resistance. It means that similar to open circuit. But we know that this one should be a meter. The pointer should move. In order to make it move, we need to provide energy. It means that current must pass through it. Of course, the current should be as less as possible. Okay. So in ideal case should be infinity, but in particle should be large value. So this one has finite resistance RV. Measure V is smaller. Okay. Now like this, smaller equivalent resistance, a smaller V are called R. Okay, smaller voltmeter reading. Okay, remember it. For the voltmeter should be measured in should be connected in parallel circuit. Okay, should be parallel like that. But once again, ROV should be greater than R to make the current to choose this path instead of passing through voltmeter. Part D, very important, because we know that all the meters should be ideal case, should be particle one, not ideal one. Okay, so what should you do? You should try to investigate the method to use the particle meter to measure the correct reading. For example, we want to find out the correct resistance. Then what should we do? We will have this one, emitter voltmeter method in practice. Okay. Now look at this. Part D. This one. Ideal meter are either the circuit, but for particle one depends on the size of R. Okay. Look at this. This one is circuit A, circuit 1. This one, we want to find out the resistance of R, but how to get it? We want to use the Ohm's law. V is equal to IR, okay, IR. But you can look at this. Circuit 1, we can have V, we can have I. Then using the Ohm's law, V over I is R. This one the same. We have we have V, we also have I. But you can find that both circuits are not the same. One of it is this V, measure including R and ammeter. But for this, ammeter will measure the current passed through voltmeter also. Then, which one is the correct one? I can say that both of them are incorrect. But in practical, you should choose the most accurate, by certain information. So look at this. Small r, it means that if you want to measure r, smaller value, this PowerPoint tells you that you should choose circuit 2. In examination, usually will ask you which circuit do you use, okay, in order to measure a certain R. Okay, now I want to explain it why. Look at this circuit. This circuit, what will happen? You can see that we want to find out VR, and this VR means that the potential difference between these 2 points. Voltmeter can show it the correct value. So voltmeter can give you true value of the potential difference across R. But unfortunately for the ammeter, this one cannot, because we want to find out IR. But unfortunately, the ammeter measure I including IR and also including IV. So this ammeter reading is wrong. Okay, but what's the problem? This reading is greater than the true value. The reading is greater than true value IR. Okay, by using this equation, what's R should be V over I. We can measure the true value, but I is greater than, okay, greater than true R. Then what will happen? This one is the measuring R, measuring V, measuring I, measuring I. Then you can find that VM, true value, they are the same. How about I, true value? It means that IR should be less than IM, but in this part. Then what will happen? Okay, you can see that this. This. Can you see it? IM is greater than IR. This one is greater than this. So the whole value will be smaller one. What is this? Will be R true. The true value is greater than the measured value. Okay, do you understand? Okay, so you can see that in this case, even we use the circuit 2. Okay, circuit 2. The answer is incorrect. What will happen? After your calculation, your answer should be less than true value. Okay, but look at this. The criteria for it is small r. Why we need to choose small r? If this r is smaller, then we will choose it. But why? Look at this. Because IV and IR. If we can find that R is smaller, but how about the voltmeter reading should be quite large, but fixed value. You cannot change it. This one, RV, you cannot change it. But R, you can change to a smaller R. Then if this one is smaller R, you can see that a large portion of the current will pass through it instead of RV, then it means that IV is a wrong part, 錯誤地方. But you can make it smaller, because if RO is small enough to draw most of the current to pass through it, then we can negate RV. Okay, then if you do it like this, of course, measuring R should be smaller than true value, but we can make IV as smaller as possible. Then finally, these true values are very near to it. It means that will be an accurate measurement. Okay. And this one is the next case. If you want to measure greater R, okay. After this, I will tell you the conclusion of it. Then if like that, then you should choose this one. But why? Once again, for this voltmeter reading is wrong because it measures VA also. Then pick out this one. For the measurement, you should get voltmeter reading, the measurement, and also the current reading measurement. But here we have the true value and also the true value. This one should be R true. Now compare it. Voltmeter reading VM include VA. Look at this. The measuring reading should be VR plus VA. This part I don't want to have it, but unfortunately we have. Then you can see that this part is greater than true value. True value, it means that VR. This one. Okay. Then you can see that this part is greater than it. But how about current? Because the current should pass through it in one way in series circuit, then this current must be true value. This one is true, but this one, this one is true value, but this one is greater than true value. Then you can find that the measured value or the calculated value should be greater than the true value. And you should know that this circuit 1 is not correct. But how to make it more correct than circuit 2? Okay, focus on this. I do not want to have it. But how? Try to make this potential drop as small as possible. But once again, we know that we have the current. How to make it small as possible? The one way is make this RA as smaller as possible. But this meter should be made by the factory. You cannot change it again. Of course, the default value of it is very small. Okay, but you cannot change it. Then what you do? Try to change this, because you can choose circuit 1 or circuit 2. If you know that R is very large, actually compare with it. Compare with RA。 Okay， 相對 RA 嚟講爭好多。Then what will happen? This part actually is the division of voltage. If you can find that RA is very small compared with VR, then you can find that this part you can negate it. If you can negate it, it means that measured R will be as the same as the true value. Okay, so this one very important. Large R, how large is it? Should be compared with RA is very large. Go back to the last line here. How small is it? This small should be very small compared with RV. Okay, because if this RV is very large compared with R, then most of the current will pass through R. Okay? Then this show you should remember it, because this one is the practical one. And in examination, this one is the long question. Ask you why you should choose circuit 1 or circuit 2, and then if I choose circuit 1, then what will happen? Okay? In example, in exercise, I will show you the other one, the other thing. Okay, chapter 14. Okay, look at this. Which of the following circuits is the most suitable for measuring the resistance of the resistor incompatible to that of an emitter? Compatible 比較啊，比較性。Now, what is it? Okay, resistor compatible to emitter. In ideal case, emitter internal resistance of the emitter should be quite small, and also this R is quite small. Then what should you do? You should choose smaller RO circuit. Okay, smaller RO circuit. What is it? Should be this. Is it? Okay, look at this again. We should choose this one. If this if this one is R, smaller R should be compared with RV is very small. Then the current may come to here, from positive to here, come to here. This one will choose, most of the current will choose this one instead of this, because this one in ideal case should be infinity, in practical case should be quite large compared with all. Okay, then emitter reading current is true, voltmeter reading voltmeter reading is true, but current reading is wrong, too large. But you can find that this part, the current comparatively will be very small, so I should be large, but is the same as the current. Then this circuit is better. How about this? This one should be greater R. You should choose it. Greater R. You should choose this one. How about B and D? D is wrong. But why? Emitter reading for ideal case. This one. ROA in ideal case should be tends to 0. In practical case should be very small, not 0. Then what will happen? If you do it like this, then you can see that from this point to this point, we have two way, one way and second way. But this way, the resistance is 10 to 0. It means that short circuit. Then what will happen? All the current come out and then pass through it and then go back. How about this one without any current? Okay, low current pass through it, what will happen? Very difficult question. You will think that voltmeter reading should be small, is it? No, you are wrong. But why? Look at this. This one is positive. This one should be positive. Here also epsilon. I think that this one is epsilon. Negative should be 0. This one 0. 0 volt. Oh, how about this? Should be between 0 and epsilon. Okay? But no. Because this one, in ideal case, should be infinity. Very large resistance. And how about this? I don't know. But you can compare it. This one is infinite. This one only R. Then by division of voltage, you can see that most of the voltage will be this portion. This one is the first method. The second method is the current. You can see that this one internal got infinity resistance. Then no current to pass through this way. Then here, even we have the resistor, but low current pass through it, low potential difference. Then this one tells us that this one should be 0 volt. Finally, in this D, what will happen? Emitter reading will be very large, tends to infinite. Voltmeter reading, what is it? Is epsilon. In examination, this question asks you many times. Okay, of course A and C is also asked you many times. How about B? Similarly, this one internal resistance will very small. Then short circuit. Come to here. I don't know here. If we know that the current should be come to here, and then choose two way. Go up or go straight. but when you go up, okay, go up, this one will be this one go up, and then the resistance will be very small. Okay, this one very small, and then this one will be short circuit. You can negate this part. And how about this? This one is infinity. Then what will happen? Use the potential approach. This one should be epsilon. This one should be positive epsilon. This one should be 0, 0. And this one, the resistance will be very small. And also, the total resistance of it is very large. Current pass through it should be tends to 0. Okay, and also this arrow is very small. Low potential drop here should also be 0. Then voltmeter reading, in this case, what will happen? Voltmeter reading and ammeter reading, what will happen? For this case, ammeter reading should be 0, because in the whole circuit the resistance should be 0 plus infinity. Okay. And how about the voltmeter reading? One side is epsilon, the other side is 0. So this one is also epsilon. Okay. So option A, B, C, D, you should notice that. What are they? Okay. Question number 2. An ideal ammeter should have low resistance. Yes. Ideal voltmeter should have low resistance. Wrong. Should be infinitely large resistance. Question number 3. This one very important, so put a star on it to tell you that which one is a better one. Which of the following two circuits give a more accurate estimate of R? Okay, and this question tells you that the current reading and the voltmeter reading, and also the internal resistance of them. Okay, but afterward, that's all, without any calculation, and then tells you the answer is circuit A. But how to know that? Actually, without any calculation. Okay, but why? Look at this. Fill in the value. For the ammeter is 100 ohm, so it means that this one should be 100 ohm. Okay, for this, inside it we have 10 kilo ohm. Similarly, for this, here we have 100 ohm. For this is 10 kilo ohm. Then what will happen? Okay, look at this. Compare with it. Compare with this R. Okay, you can see that this one is 4.6 volt, and this one is 0.91. Okay, here we will usually think that this current should be very small. Okay, should be very small. And then now this one we want to know that which one is a better one. Then what will happen? You should try to compare it using the ratio. Okay, ratio. Because in this case we want to have a R, but up to now I don't know what's R. R should be smaller or large. Okay, compare with this. Okay, then what should you do? You try to think that because this one voltage 4.6, you can try to calculate 4.6. Okay, and then how about this 100 ohm? Okay, 100 ohm. But you know that the current. So this one 100 means that this one 0.91 m. It means that over 1000 and then times 100 ohm. Then you can see that for the potential drop across the emitter after the calculation should be 0.091. Okay, but this point and this point at least 4.6. Okay, and after the calculation you can see that the potential drop across R will be 4.5 something. Okay, and then how about this? Here we can see that this one is 4.5 volt. Okay, and here we know that the current should be this 1.35. This current 1.35 should include the current pass through this way. Okay, then what will happen? Because the reading show that this one is 4.5 volt. 4.5 volt means that this one and this one should be 4.5 volt. 4.5 volt across this one. Okay, so this part, the current pass through it should be 4.5 over resistance. This. Okay, and how much is it? How much is it? This one, you can see that this one should be mini, and then 0.45 mA. And how about this? This one should be 0.9 mA. Okay, then what will happen? Now you should compare it. Here, in this circuit, we want to make the current at most pass through R, only a small portion pass through V, then we can get the correct result. But after it, you can see that the current ratio only 2 to 1. Can you see it? This one is 0.9, this one is 0.45, 1 to 1. And then how about this part? This part is not division of current, should be division of voltage. What can you see? You can see that this potential drop is 0.091. And how about this is 4.5. You can see that many ways. For example, this one is 1. This one should be 45 times. Can you see it? Then you can see that the ratio can tell you that which one is more accurate one. Circuit A will be more accurate one. But how to use it? How to try to use the division of voltage or division of current to find out the ratio. If the ratio between them is as large as possible, then this one will be the accurate one. This question you also will be done in exercise or online tutorial. Okay, that's all.